Hello and welcome. Today I'm going to offer an overview of our carbon dioxide and combination carbon dioxide, relative humidity, and temperature transmitter product lines. These can be used in HVAC, building automation, and demand control ventilation applications. Developed from the ground up, the sensor technology at the core of the Dwyer carbon dioxide product lines features a non-dispersive infrared sensor in a single beam dual wavelength configuration. The primary advantage of our CO2 sensor design is that it can be used in occupied or unoccupied building applications. Over time, the light source used in NDIR CO2 sensors dims, creating drift in the sensor readings. With other sensing technologies, this is corrected for using algorithms that automatically self-calibrate the device. Unwanted errors can be induced by this self-calibration procedure, especially in cases where the space may be occupied 24 hours a day. Featuring the Dwyer patented Digital Intelligent Temperature Compensation algorithm, our combination sensors eliminate errors in the RH readings caused by the natural internal heating effects of wall mount combination sensors. The circuitry needed to drive NDIR sensors creates heat inside the enclosure. Since wall mount sensors are not typically mounted in a location where there is significant airflow to draw this heat away, the result is typically a higher temperature reading and lower RH reading than the actual conditions in the room. The North American and European wall mount combination sensor housings feature a separate temperature sensor that is thermally isolated from the internal space of the enclosure. This has been tested to prove a more accurate measurement of the airspace temperature, which is then used to more accurately represent the RH level in the room. This is not used in the duct mount sensors as the airflow across the sensing element draws away the heat created by the circuitry. Dwyer offers 3 different product series to cover the variety in building specifications for measuring carbon dioxide levels in a building space. First is the series CDT. This line features CO2 and temperature outputs only. The CO2 output signal can be field selected between voltage and current options, while various thermistor and RTD temperature outputs are offered at the time of order to match the input needs of the building management system. Next, the series CDTR builds off the same CO2 and temperature sensing options as the series CDT, but adds an additional output measuring relative humidity. Like the CO2 output, the relative humidity output signal is field selectable between voltage and current options. The third product series is the CDTA. In this series, temperature set point and manual override features are available in addition to CO2, RH, and temperature measurements. Here, all of the measurement and user setting values are communicated via BACnet or Modbus over an RS-485 connection. Each of these product series are offered in one of 2 wall mount designs, aesthetically designed for the global marketplaces, or a duct mount configuration for the CDT and CDTR series. User interface buttons are discreetly located on the side of the wall mount housings, while menu lockout setting and a cover set screw are offered to prevent unwanted adjustment of the device. Wall mount models can be ordered with an optional LCD display. This can be configured to show any combination of CO2, relative humidity, temperature, or temperature set point, depending on the product series. For duct mount models or wall mount models without a display, the accessory display tool model A-449 can be used to see what the device is reading without the need for a permanent display. With the various carbon dioxide transmitter options available, Dwyer has your CO2 sensing application covered no matter what the requirements. For more information on these or any other Dwyer product line, please visit our website.